Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be learning how to solve a problem on Lami's theorem. Let us look at the problem. You have a 4-bar mechanism in which you have 3 bars are pinned together at B and C and supported by hinges at A and D. So this forms a 4-bar mechanism, and here the value of the force is given that 200 newtons is acting at joint B, and the moment if it is acting, if there is no P, it is going to deform, it is going to move. So to prevent the motion of this particular 4-bar mechanism, what may be the magnitude of the force P required to have to prevent the motion? Means it is to keep in equilibrium. So this particular problem you have to solve in such a way that applying Lami's theorem. So let us draw. First you draw the free body diagram of joint B. This is the joint, right? So from free body diagram of joint B, let us represent the moment 200 newtons as well as P is acting, the forces are developed. Internal forces are developed in AB, BC as well as CD. So let us assume that the internal force in member BC is FBC. You have represented away from the joint B. Similarly, a force in AB, that is force in AB, is represented away from the joint. So let us see that a body is subjected to, a joint is subjected to 3 forces, and you can apply Lami's theorem to calculate this particular force FBC. So each force is proportional. This angle you have to evaluate. So 360 minus 75 plus 45. So this is 120 and this is 240 degrees. So now by applying Lami's theorem, you want to calculate a force in member BC, FBC divided by the angle between the other two forces, that is sine 75 degrees, is equals to the known force, that is 200, divided by the sine of angle between other two forces, that is sine 240 degrees. So from this you can evaluate the force in member FBC. You are going to get it is minus 224 newtons. You are going to get with the negative sign, right? And let us draw the free body diagram of joint C. In this, you can represent this force FBC away from the joint. Similarly, the force in member, it is a force in CD, and of course P is there. So you want to calculate this particular force P. So in order to calculate force P, let us again apply Lami's theorem. You can write down. So it is a free body diagram of joint C. So this is a joint. So you want to calculate P value. So you can write down P divided by sine angle between the other two forces. This angle 360 minus 60 plus 45, that is 105. This gives you 255 degrees. So it is sine 255 is equals to force FBC is known, that is minus 224 divided by sine of angle between, it is the other two forces, is 45, sine 45. So from this you can calculate the P magnitude of the force P. You are going to get 305 newtons. So you can understand the importance of Lami's theorem. You have applied Lami's theorem by considering equilibrium of joint B as well as joint C. Thank you very much for watching this video.